Yeah.
So coming to today's topic, it is called time series.
Yeah.
Okay. And the way we talk about time series is that, okay, let's go to this data first. Data set. Okay, so air passenger, this is the data. So if you see here, we have time and we have data. That's why it's called time series. So 1949 January month, 49 Feb, 49 March, 49 April. So May, okay, then 50, okay. So the data, okay, it is like number of passengers traveling by air. Number of passengers traveling by air, it depends upon the month, right? You know, it said on which day, is it today or this week or this month, last month? So that's why it's called time series data. Okay. And let's say, you know, we take this 20-year data and we will, you know, predict what will happen in future. Okay.
Okay.
So this is data visualization. You can draw this. And when you do the visualization, you see this trend here. This is your graph. This is the graph you get the data.
Okay.
Now, what do you see? Overall trend, you see it is increasing, right?
Yes. Yes.
Overall trend, it is increasing. Now, it has you know, other features as well. You see there are, it goes up and down, goes up and down, right? It increases then falls below, it goes up and goes down. Okay, so if you start breaking this into, you know, a different form, okay, you get, okay, so look at this graph now. I have broken into different form. So if you see here, this line is an overall trend. Overall trend is like taking average of the year. So
Okay.
1949 is the average of all the 12 months. 50, it is average of all 12 months. Average of all the 12 months for 2051. So if you take average, of course, you get only one value, right? So
Yes,
this
sir.
is what you get as a straight line. Then this is called as seasonality. Within 12 months, okay, the number of people traveling will not be same. Particular month, maybe the Christmas time, people will travel more, maybe Thanksgiving, Christmas, in I'm talking about the US, right?
Okay. Yeah.
In
Yeah.
our case, when the Dashara, Diwali, people will travel,
Yes.
right? So the travel during those time is very high, right? So it's
Yes.
called seasonality. Now seasonality will happen, so there is something called as seasonality and cycle. Okay, cycle also goes up and down. Okay, seasonality will also, okay, let me talk about it. Okay, so you know, cycle is something like economy. Economy will be doing very good GDP. It will start falling down after again, you know, after 2 years it will fall down, it will go down again, it will start going up, right?
Yeah.
This
Yeah.
is pattern that you see in economy, right? Economy will not be all growing every time. Maybe 2 years it will be good, then it will come down for some reason, again it will go up, right?
Yes. Yes, sir.
Seasonality also happens like that.
Okay.
Okay, let's say you talk about um, uh, paint sale, you know, how much paint are you selling? So maybe in January it will be less. Okay, slowly it will increase. In October, November, the paint sale is very high. December,
Yeah.
again it goes down, again it goes up. Okay, now if you look at pattern, both are same. Okay, is also low high, it's not same all across. Okay, but difference is cycle. Okay, there is no fixed timeline. That means it can happen over 2 years, 3 years, 4 years, right? We know what goes up has to come down, but
Yeah.
when it
Yeah.
will come down, we don't know, right?
Yeah. Yes,
So
sir.
cycle is which happens, you know, it takes more than 1 year to happen. Seasonality you will see within the same year. Okay, January. So whatever you see from Jan to December, okay, same. Okay, let's say Jan to uh, you know, Jan. So December will be somewhere here, right? October highest paints Diwali time, people will paint their house, right? Then
Yes.
slowly it will decrease and it comes down. January is here. So same pattern repeats in year, annual pattern. So seasonality is always what you see in an year, not more than a year. Sale of umbrellas, sale of sweaters, sale of AC. All these are called seasonality, seasonal. Okay, in season the sale will be highest. In summer, sale of AC will be highest, and lowest will be in the winter time.
Yeah.
So this trend, if you see, if this trend, if you see within a year, we call it a seasonality. And if it is more than a year, it's a cycle. Like economy is a cycle. It's not a seasonality. Not that every year, January, your GDP will be highest, and December it will be lowest, again January highest. No. Okay. So cycle, there is no fixed timeline, and definitely it is more than 1 year. We look cycle over 5 years or 10 years. But seasonality, you will see the pattern every year. Okay. We can have weekly seasonality. If you go to restaurant, if you see Saturday, Sunday, the more people will be there. Okay. Monday will be less. Wednesdays, generally you will see the least number of people going out. Okay. So if you look at weekly seasonality, okay, you will see more people going on weekend, right?
Yes.
So that's again a seasonality, weekly seasonality. So when we go to time series data will have the trend. This is called trend. This is called seasonality. What you see here, you see perfect in exactly same pattern you see every year. You see that?
Yes, sir.
Same pattern you will see. That's called seasonality.
Okay.
And this is noise. There, of course, there will be some noise. Okay. Sometime, some month, let's say, due to some other thing, there's a high snowfall, or in India, in Delhi side, you have this fog, right? So even though it is the peak time, okay, but due to fog, the no flight has taken off on that day, right? So that day the travel will be zero. Okay, so that's called noise. Noise is something which you can't predict. Okay, but it will have impact on the analysis. So this is noise. Okay, so generally we remove the noise. Okay, noise we can't predict, so we remove the noise. We can only predict time series analysis when you have trend and seasonality.
Okay.
Noise we tend to remove, because noise we can't do anything.
Okay. And
Hyderabad Bandh. Okay, people have called for Hyderabad Bandh. Now, even though it may be a Ramjan season or Diwali season, if there's one day Bandh, you will not be making any sales, right? But then what happens? Next day you'll have double sales. Okay,
yes.
so the seasonality is maintained. Yeah. So okay, so this is what you see. Okay, trend. Okay. Now time series can be your additive time series or multiplicative time series. Additive time series, all these three are added. So base level is what you see today. Trend going upward. On average, it grows by 5%, right? So it will grow. Next year also it will be 5% only. 5% on what it is today. But then the month-wise daily sales, if you look at, or weekly, whatever you're looking at, will be different. So you add base level to plus trend plus seasonality plus error. Okay. Multiplicative is like when you multiply, no? So the values are much higher, right? But whatever, okay. But you can clearly see all these three things, and this code will actually decompose dot seasonal, decompose dot residual. Resid stand for residual error. So this will give you, this will decompose, this will take out the error from the graph. Okay.
Noise component, sir.
Noise component, seasonal component, trend component. So decomposition dot trend will give you trend. Decomposition dot seasonal will give you seasonal. Decomposition dot residual will give you error. Okay. And then you can draw a plot for each of these three values. Okay. This is part of your stats models.
Okay.
So this is just to see. Okay. And when you look at this, you will know whether your data is time series data or not. Okay. When you have trend, when you have seasonality, okay, that's when you can apply a, if there is no trend, then you can't apply time series data.
Okay.
So these are the features of time series data. which you can
First, we need to visualize the data. Based on that, we have to decide
Correct.
whether we can.
correct. So there is, you can visualize, or there is a test also.
Okay.
Okay, stationary and non-stationary time series test. So it's called, okay, you have augmented Dickey Fuller test, ADH test, you have this KPSS test, or you have this PP test. Okay, so this talks about how to perform. So see, when you have this okay, time series data is stationary. Stationary means there is no trend in that. Okay, so if you perform ADF test, and if the p-value is more than 0.05, we accept the null hypothesis that, okay, there is no stationary, I mean, there is stationary, the data is not, does not have any trend. Similarly, you can perform KPSS test. Okay, so so this will tell you, okay, so you can actually see the data and then perform the test. You can correlate, just like, see, you can find median, or you can also create box plot. Box plot will give you median, right? Or you can directly find median.
Okay.
Okay, so how to detrend a test series? Now, see, I need to find the base value, right? So you need to do the detrending. You have to remove the trend. Okay, see, trend is like, you have a base value. Let's say base value is 100. Now, if the trend is 5%, depending upon how far you are going, I want to predict for tomorrow, right? I'll apply trend on whatever data I have today. If I have to apply, if I have to check for day after, right? I'll have to apply two trends, right? Two trend. Okay. So first, it is important to find today's base value. That's why we are doing detrend. And when you are predicting, more farther you predict, more inaccurate you will get the data. Okay, it is easy to predict what will happen tomorrow than what will happen day after. Right?
Okay. Yeah.
Right. So
Yes.
so that's what we are doing here. So when you remove the D trend, okay, this is how you remove the D trend. So see, trend is increasing, isn't it? We have removing the trend. So now if you remove the trend, you will have a straight data. So, okay, so you end up performing all these steps. Okay.
Yes, sir.
Okay. So this is also done. And if there are missing values, okay. So if there are missing values, how do you find the missing values? Okay. Now, let's say you have data for Jan and you have data for March. So how do you find missing value for February? Right? Okay. So there are multiple ways. Okay. There's something called a backward fill, linear interpolation, quadratic, mean of nearest neighbors, mean of seasonal counterparts. Okay. So this is if the data is missing, right?
Okay. Yeah.
So now if you look at, let's say you have data for Jan and you have data for March, but you don't have data for February.
Okay.
Right?
Yeah.
One option is, okay, mean of nearest neighbors. So you take mean of these two,
Okay.
right? Or you can decide to have mean of these four. So you have to take equal number of neighbors both the side, right? You have to take equal number of values. So if you either take two values on the left and two on the left, or one on the left, one on the right. Okay, so this is called finding average of nearest neighbors. Sometimes we also perform what is called as uh, average of seasonality. So you have like for February, right? So instead of looking at the neighbors, don't look at the neighbors, look at the February data, okay? Because seasonality happens based on a month, right? So if you have to find for a month, you take the average of February and February. Okay.
Cycle
Now,
values.
cycle, yeah, not cycle, seasonality. Okay. Cycle is for more than 1 year, right?
Yeah,
So
that's what.
cycle in time series has a different meaning. Okay. So not the cycle, but the okay, but the the seasonality period. Okay.
Okay.
So sometimes let's say if the sale is generally high in February, let's say sale is generally high in February and low in Jan and March. So if you take average of Jan and March,
Yeah.
okay, it will be lower than what generally you would see.
Yeah.
Right.
What may
Right?
be real value? Yeah.
Right.
Yes.
So okay, so looking at the data, looking at whatever we have done, right, you have to analyze and decide which method will be better. Okay. Quadratic interpolation is when you take square of the value. Okay. Linear interpolation is okay, so linear interpolation you can even do like last 3 months. Okay, so let's say this is February, you will take average of last 3 months. Okay, but may not be in the same what do you call them, may not be in the same same weight. You might give 3 times weight to this nearest value, 2 times weight to this, and 1 time weight to this. That means you will multiply 1 with this, 2 with this, 3 with this, add them and divide by 6. So it is like as if you have 6 values. Okay.
Yeah.
So then what we are doing, we are giving more importance to the immediate value.
Okay. Understood, sir. Yeah.
Okay.
Yeah. Yes, sir.
Okay. So so this is how you will replace if there are some missing values, and code is there here. Okay. Then directly we'll go to prediction. Now here there are something called as autocorrelation and partial correlation functions. Okay, so what do you mean by autocorrelation and partial correlation? See, you can directly perform this function, this but these things are there to just understand the time series data. Okay, how um, uh, how do you understand from the time series data basically, right? So where is autocorrelation? Okay, so lag is nothing but the period. Okay, previous period. So if I say, okay, so you have data till let's say August 2022, let's say. Okay, so you have data till August 2022. So after this, whatever you are doing is prediction, isn't it? For September, for October, right? So so this is called lag 1, lag 2, lag 3. Now see, in this case data is monthly data, so each lag is about a month. Okay, 30 days of. You can have a weekly data also. Okay, time series need not be monthly, it can be quarterly, it can be weekly, it can be 15 days, fixed timeline. So we need to find if there is a correlation that can happen between previous timeline. Correlation is again kind of it's kind of your trend only, right? It okay, and then you see if there is any change here. Now, if you see here, lag 1, lag 2, okay, lag 3 means t plus 3, right? You are predicting for third this thing. Okay, so how does it work actually? Okay, so before we talk about this, how does time series work? Now, we need data for one complete cycle. If you have more, great. Okay, otherwise we need the data for one complete cycle. So in this case, let's say if you are focusing on monthly, right, you need at least 2 years of data. Okay, so 2 years of data. So if I have to predict for September 2022 or October 2022, I need to have data till August 2022, and this is your July, no, September, right? September 2022, and this is your September 2021.
Okay.
Or you have better, but minimum you need to have, you know, these 2 years of data. Okay. Now, all the trend, correlation, seasonality, you will be able to notice from this. So now, so based on this data, you are predicting for this, right? Whatever you notice here, okay, autocorrelation, seasonality, same thing you will try to implement here when you are trying to predict for this. That's why we need 2 years of data. So it's like you are watching this, and this is your kind of training data, right? You're watching this and you're learning, okay, this is what it was. So this is what it is going to be in September here. Okay, this is what was in October. If this happened, this is the output. So if this is the input, what will happen in October? Understood?
Yes, sir.
So we are learning from, you know, previous to previous period, understanding and then confirming, checking, validating with the last year, and whatever you learning you have made, same learning you are implementing for the future period. So if you have less number of data, you will get some output, but you know that is not you know what maybe accurate data, right? So at least 2 months of, if we have 3, even more great. So based on this, you are learning here. Again, based on this, you are learning here. Now you have 2 periods of learning, 2 years of learning, and you are implementing on the 3rd year. So more you have, better it is. But at least you should have 2 full cycle of data. Okay. So this
Yes,
is what we are learning and seeing how the lag happens. Okay. And I'm not going to get into functions. You can practice this. Okay. And okay, so these are all your turn learning. Now to implement, we use ARIMA model. Okay, ARIMA stands for auto regressive integrated moving average. Auto regressive integrated moving average. Okay, so it, you know, it takes average of your 3 period and it is going to predict. Okay, so again, ARIMA is the most popular algorithm within time series. Okay, as the name suggests, it is moving average. Okay, where is it? Okay, so moving average means, okay, you are taking average of this data. So for predicting September, you're taking average of September data. For predicting October, you are taking average of October data. Okay, and then, you know, you are predicting. That's the ARIMA model. So so whatever, where did it go? Okay, so now okay, ARIMA has 2 things here: auto regressive and moving average. Moving average, I told you, right? You're trying to find the average value of moving period. Auto regressive is adding those trend, seasonality, okay, error, okay, to this. So the actual value, non-stationary value, okay, will give you the moving average, and then you apply your seasonality, your trend. Trend is 5%. So whatever output you get, you add 5% on top of it. Seasonality, you add seasonality pattern on top of it. Okay, so that's why we call it as ARMA. Okay, and then you directly run it, you get. I mean, see, you can directly run this. You don't have to, whatever we have done so far is just to understand, visualize, to see the model. So algorithm is only this much. Okay, and when you run it, okay, and of course, okay, this is what, no, not this, right? Okay, again, same thing. Prediction I wanted to see. Okay, this is your prediction. Okay, now if you change the time here, this is, okay, prediction. Okay, and where is the, this is log. Okay, okay, so the green line is actually the prediction, and orange line is your the actual value. Okay, and of course this is the RMC error. How much is the error? Okay, so I'm just looking at the prediction here. This is all plotting the graph. Prediction here. Okay, so this is the data and order. Okay, 110. What is 110? You have seen those three variables here. PQD. So I'm saying P equal to 1, Q equal to 1, and D equal to 0. Okay, there is no stationary. Now 110, okay, you have to play with that. Okay, just like, to find what is the right value of PQD. D is the difference that will make it stationary. 0 means you are assuming that the trend is stationary. If you get decay flow test as stationary, you'll put D as 0. Okay, P and Q is the weightage. Should you give more weightage to average value, or should you give more weightage to the auto regression value? Right, so when you say 1 1, it means you are giving equal weightage to both of them. Okay, and then you go ahead and predict. Okay, same stuff, we are doing it again actually. Okay, so there's less, earlier we had all that discussion. Now we are going ahead and running a time series algorithm here. Okay, so order is 110 PQD value, ARIMA model. Okay, then this is to plot. Okay, okay, predictions ARIMA diff head. Prediction. Did I miss the prediction part?
In building the model only, we have this.
No, so I think we are not predicting for new. So, the orange line that you see, right? This is the prediction. Okay. So we are actually predicting for we are predicting previous year data for the next year. Okay. So, but how do we predict for the future? Okay. That's what I was saying. So orange line is for prediction. Okay, so the orange line that you get is to predict. Okay, that is correct. But if I have to give the data, how will I predict it? So see, we are predicting the same data. So I'm just thinking, where are we passing the period here? So ts log dot fit. Okay. Okay. And results dot fitted values. This is where, so this is plotting, right? Title, PD series, prediction dot arima. Where are we?
Up, sir, up.
Here, right?
Yeah.
PD series dot fitted values. So results dot arima, results dot arima. Okay. So this is what we have fitted. I think we haven't. So we are fitted, and it tells us the error that it has with the training data. So this tells you the error with the training data. Okay. Now, if you have to predict it, okay, so we have to give new function here. Okay. Uh, okay. See, this is the cumulative difference. Okay. And if we can add, this is fine. Prediction arima log, right? Prediction arima log, this is the prediction. Okay. But if here, if you give the different set of values, right? Okay, we are giving same set of values. So it is predicting same set of values. If you give different set of values, then you will get a prediction for the different set of values. Okay. So what I'm thinking is, I will change this. Okay, and I'll give the same code. Okay. After that, I will add new data and I'll send you.
Okay.
Okay. So what happens, like till 9? No, we have, this is till 61, isn't it? This is the predicted part. Okay.
The green line is predictions or what, according to the text?
No. I am thinking. Uh, See, looking at the data here, we have data till 1960, correct? But if you see the output,
It crossed after 1960.
yeah. So Where is it taking the one period? Okay. So results are fitted values, first row. So fitted values, we are saying leave the first, uh, like not the first row, but from second till the end. Okay. Okay, so let's try to build this from scratch. It's 11:30. That's what I'm thinking. If I so I'll do it tomorrow. Okay, I'll code it tomorrow.
Okay.
Okay, so we will take this same data set. We will
Okay.
we will not perform test. We'll assume data is ready for analysis. We
Okay.
will remove trend seasonality thing, and then we'll get into prediction. Okay,
Okay.
test and drawing those graphs, you can do it. Main
Okay.
thing is how to predict it, right?
Yes,
So using ARIMA model will predict it.
Okay.
Okay.
Yeah.
Yeah. So
Previously, you have given first time 5 projects, no, sir. In that cryptocurrency price prediction also comes under this
yes, yes.
time series. There I got error running the program, sir. It was
What error you got?
prediction part. It was iterating continuously. That day we said, no, sir. Yeah, you said we discuss it when we deal with time series.
Time series. Okay. Okay.
Yeah.
So yes, we'll see that one also.
Yeah. Yes, sir. Okay, sir.
Yeah. Sure. So let's finish off time series tomorrow. I'll do the
Yes.
coding. I'll show you. Yeah.
Yes, sir.
Here it's probably like if I want to try something, I can't do it.
Yeah,
right?
yeah.
So
Yes, sir.
I'll type the code and then I'll show you.
Okay, sir. Okay, sure.
Okay. So this is the square. Prediction ARIMA is the one. Now the prediction ARIMA is coming from NP2 exponential ARIMA log. So now we'll see what is ARIMA log and we'll predict it tomorrow. Yeah. Okay, sure then. See you then tomorrow. Okay.
Yes, sir. Bye,
Yeah.
sir. Bye, sir.